Okay, as I said before, all the measurements are approximate. So remember that I wrote the number 1373. Okay, this number would be in between two limits, let's say. One limit it's going to be 1,300, and the other limit would be 100, sorry, 1,400. Okay, somewhere between these two numbers, you are going to find the measurement. Okay, imagine these are centimeters. Okay, perfect. Remember that when I wrote this number um, like this, I wrote 1,000 because I took number 3. Okay, the position thousands is occupied by number 1. The next number is number 3, and you don't have to round the number up because number 3 obvious is smaller than 5. That's why I wrote 1,000. Okay, let's continue a bit more. Uh, this is a group of numbers that the original measurement is somewhere between. That's why I wrote on the previous part, uh, as these measurements are approximate, there is a group of numbers that the original measurement is somewhere between. If we talked about, we talk about, I don't know, a ruler, for example, a term, um, how we measure the fever, for instance. Okay, all these are approximate. So we are going to deal with the limits of accuracy. We have the definitions. The upper bound is the smallest value that would round up to the next estimated value, and in other words, is the largest possible number. Okay? And the lower bound is the lowest possible number, or the smallest value that would round up to the estimated value. So here we are going to work with this example. What is the upper bound of 9.58 seconds to the nearest 0.001 second? First of all, remember that when we are dealing with this kind of expression to the nearest 0.001 second, it's a way of mentioning the degree of accuracy in a generic way, okay? Es una manera genérica de nombrar el grado de exactitud. ¿Se acuerdan que nosotros decimos, si no, to the nearest tenth, to the nearest 100, to the nearest 1,000, okay? And if we go to the smallest numbers, to a number more related, that has decimal places, we use also 0.001, for example. Okay, perfect.